Escualene is a natural compound, a precursor of various hormones in animals and sterols in plants. It is considered a molecule with pharmacological, cosmetic, and nutritional potential. Scientific research has shown that esqualene reduces skin damage by UV radiation, LD levels, and cholesterol in the blood, prevents the suffering of cardiovascular diseases, and has anti-tumor and anti-cancer effects against ovarian, breast, lung, and colon cancer. The inclusion of esqualane in the human diet is recommended without causing health risk. However, its intake is low due to the lack of natural sources of esqualane and efficient extraction methods, which limit its commercialization. Biotechnological advances have developed synthetic techniques to produce esqualane.
And now, something that is important to know about squalene, its history. The first source from which squalene was obtained was shark liver. In 1916, by Matsumoto Tsujimoto, identified a highly unsaturated hydrocarbon was identified from liver oils of scholar sharks. He proposed the name squalene. Squalene was obtained from shark liver. As low density liquid, people use it for neutral buoyancy effects. And now, how can we tell the molecule? Natural name and UPAC name. We should know the two names that it has the molecule. The natural name is squalene, but the UPAC name is 6C, 10E, 14E, 18E, 2, 6, 10, 15, 19, 23, hexamethyl tetracosa, 2, 6, 10, 14, 18, 22, hexene. Squalene is a triterpene consisting of 2, 6, 10, 15, 19, 23 hexamethyl tetracosane, having 6 double bonds at the 2, 6, 10, 14, 18, and 22 positions with 6, 10, 14, and 18E configuration.
As physical, chemical, and structural properties, we can say that esqualane is a triterpenoid of 30 carbons and 50 hydrogens with 6 double bonds. Physically, it's a transparent oil with a molecular weight of 410.7 grams per mole. It has a density of 0.855 grams per cubic centimeter and a melting temperature of minus 20 degrees Celsius, a boiling point of 355 degrees Celsius, and it is soluble in organic solvents and insoluble in water. Squalane is important as the biogenetic precursor of steroids and triterpenoids. Its structure contains as complicating elements 3 substituted olefinic linkages.
Reaction mechanism and product. Epoxidation of squalene. Biogenesis of lanosterol and cycloartenol. This process begins with the cyclization of squalene when molecular oxygen, NADPH, and soluble and microsmall levels fraction are present. The epoxidation of squalene begins with the incorporation of molecular oxygen and is catalyzed by a monooxygenases, specifically squalene epoxidase. In the second reaction, which occurs in animals and fungi, lanosterol synthesis is involved are cycles that cyclization leads to lanosterol tryptophan. The second reaction in transgrowth plants by a different route. It catalyzes by cycloartenol synthesis and tryptophan cycloartenol is obtained.
And now we're going to talk about the industrial method and the laboratory method. There are two ways to get squalene. One of them is the industrial method. That method for obtaining squalene is from distillates from the physical refining of olive oil. The method comprises performing an alkaline saponification of the raw material in presence of an isotope and high vacuum molecular distillation of the unsaponifiable fraction. In the image, we can see bulbs, heat exchangers, distillation towers, capacitors, and other kind of machines. But the other way to get squalene is the laboratory method. One of the most interesting technology to obtain squalene from biological matrix is supercritical fluid extraction with CO2, a solvent because of economic, safe, and easy removal characteristics.
Use of squalene. Squalene has application in industry such as cosmetic, food supplements, pharmaceutical, and in another application like high-grade lubrication and fabric-coating additives. However, the major date of commercial is referred to short liver oil (SLO). In the USA, SLO was used for vitamin A production, but now is highly recommended in alternative medicine on ointment. In Europe, the SLO is mined by cosmetic industry, selling products as lotions, eyeliner, eyeshadow, eye makeup remover, and perfumes. Contain 0.1 and 10% squalene. Lipsticks and other face preparation contain up to 50% squalene. Pharmaceutical, textile, and leather industry also demand squalene. In Africa, SLO is mainly used on fishing boat maintenance.
Environmental impact. The richest source of esqualene is abyssal shark livers. 3,000 livers are needed to have a ton of esqualene, and the massive depletion of sharks caused that some species were in the red list of endangered species. Nowadays, the technology is searching alternatives to obtain esqualene as in vegetable sources and microorganism sources.